I did a bit of de Moivre's theorem here from the core further maths content. It's the FP2 from June 2024, question 4. Now this question says, use de Moivre's theorem to show what cos 6 theta is, well really in terms of cos thetas, and then solve that equation. Well, you've got to do it with the substitution. But I'm going to show you, it's straight out of the textbook, this question. So there must be running out of questions at Pearson. But it's loads of work here for 4 marks. So we're going to try and slim it down a little bit. So here's de Moivre's theorem. We've got cos 6 theta plus I sine 6 theta. That's the same as cos theta plus I sine theta to the power of 6. But I'm going to use the cis notation. CIS 6 theta, cis 6 theta is cis theta to the power of 6. And also C for cos theta and S for sine theta, because it's too much effort right now every time. So here's my de Moivre's theorem really. I've replaced the cos theta with C, sine theta with the S, and I've got cis 6 theta over here. And to work it out, I'll just use binomial expansion. So C plus IS all to the power of 6. So the first term is just C to the power of 6. And then we've got the end C1, which is 6. And we'll have C to the power of 5 times IS. And it's these IS's we want to get rid of really, because we just want the real part of the expansion, because we just want cos 6 theta, which is the real part. Then moving on, NC2, 6C2 is 15, that's C to the power of 4. The next one is going to be N6C3, which is 20, and it'll be C to the power of 3, IS to the power of 3, and so on, and so on. And the last term is just IS to the power of 6. Now, I want cos 6 theta, which is, so I don't want this, I want the real part of that expansion, or the real part of this. C to the power of 6, well that's cos to the power of 6, so that's alright, that's real, hasn't got any i's in it. But this term has, so I'll just get rid of that straight away, I'm not interested. This one though, well, I squared is minus 1, so that's going to be real. So it becomes minus 1, so I'm going to have C to the power of 4, S squared, but I'll have a minus 15. This one's going to be minus I when I cube I, so that's imaginary, forget about that one. This is going to be real because I've got I to the power of 4, and that's equal to 1, so it's just going to be 15c squared S to the power of 4. This one, well, I to the power of 5 is I, so that's imaginary, and get rid of that one. And then we've got I to the power of 6, which is minus 1, so that's real, so we've got minus S to the power of 6. But I want it all in terms of just coses, not coses and sines, so I'm going to have to do a bit of work on it. Use the sine squared is 1 minus cos squared, so that term's alright. But this one, I'll write as C4, C to the power of 4, and then 1 minus c squared, sine squared, 1 minus cos squared. Same with this one, but that's sine squared squared, so it's 1 minus cos squared squared. And then the last one, well, that's sine squared cubed, so it's 1 minus cos squared cubed. Then I've got to do a bit of algebra, so multiply some brackets out. This one here is alright, just multiply by 15c to the 4. This one, I'm going to square it and multiply by 15c squared, because I'm all further maths. And the last one is just cube it. And then I'm going to multiply by 15c squared, I get that. This one, just change the sign. And then I'm going to simplify it, I do get 36c to the power of 6, 48c to the 4. Plus 18c squared minus 1, and then now you'll need to write it in that form at the end. They'll be happy with this in the working, I think, but you need to write the complete form out at the end. Right, then the second part, hence determine the smallest possible root of that equation. It says hence, so we've got to use the first part, we've got to use the expansion for cos 6 theta. And so if we compare it with the equation, 48 is 1.5 32s, the 72 is 1.5 48s, and the 27 is 1.5 18s. So if we use a substitution, x equals cos theta in here, and put that equal to c, we can write 48c squared, c to the power of 6, minus 72c to the power of 4, and all this lot, that's 48 cos to the power of 6, which I'm going to write as 3 over 2 times 32, because it's at 32 in there I want, because I want to change all this into cos 6 theta. 48 and 18. But I need a -1 in there to make it cos 6 theta in the bracket, which means I've got 3 over 2 times -1, so minus 3 over 2. But in my equation, I've just got -1, so I need to add on a half to make it right. I've just got -1 there. And I say that that bracket is just cos 6 theta. So 3 over 2 cos 6 theta is minus a half. So cos 6 theta is minus a third. Now, to find out what x is, well, the x is cos theta. I know I can work out what 6 theta is by doing cos to the -1. And you think, oh, the 6 theta, well, plus or minus 1.91 when I do cos to the -1 of that. Divided by 6, I get that. So my x, which is cos theta, 0.94972. That's quite big for a cos. Because cos go to 1 and down at -1. And we're looking for the smallest value. So if you do 2 pi minus the 1.91, you get this. Divided by 6 and do the cos of it, 0.746. Still not found the smallest one yet though. If I do 2 pi added onto the 1.91, I get 8.19, divided by 6 again, and doing the cos of it, I get 0.2037. It can be plus or minus, of course, because the symmetry of the cos graph. And then if I do 2 pi added onto this one, I get 10.65 divided by 6, and do the cos of it. And then it all starts repeating then. So there's actually just 6 roots, which is what you'd expect for an equation with x to the power of 6 in it. So, and the smallest positive one is that 0.2037, and we want it to 3 decimal places, so 0.204.